Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today we have a very special guest, triple special, Sequoya Cross. She's been in the solar industry for a long time. It's hard to believe. And she has a great job over at Briggs and Stratton. And I've known her doing some other things. So I remember that Sequoya was also the president of NorCal Solar, which I'm the president of now. And I didn't steal it from her. I didn't kick her out. It was not a hostile takeover. She was gone before I was even on the board, I believe. And I remember she was working at Backwoods Solar, and they help people with off-grid solar, super cool stuff. And so when people would have questions about off-grid solar, I would send them to Sequoya at Backwoods Solar. And she also worked with Tamarack, and that's kind of sort of related to Backwoods. And another thing too is with AEE Solar. I think that's where Sequoya got her start with David Katz. And I remember one time I just kind of bumped in and met David coming back from Germany. We happened to sit next to each other on an airplane for a whole bunch of hours, which was really cool. And I learned a lot there. And then also Sequoya is on the CALSA board, which is a very important board. And that's the California Solar and Storage Association. And right now, Sequoya is working for Briggs and Stratton, and they acquired a really cool battery company called SimpliPHI. And the thing that I was hoping to talk to her about the most is there is this DC only energy storage system, and I've been looking for one for a long time, and this is the first one that I found, and it was kind of weird how I found it. I was introduced to it by CT Greenbank, and CT stands for Connecticut, and I'm doing some consulting for them, and they're like, what do we do with this? Is this for real? Like, how does this work? And I was like, man, I've been looking for one of those. And then I just happened to bump into Sequoya that night at the CALSA banquet, which was super cool. So welcome to the show, Sequoya. Did I get everything right?
Yeah, for the most part.
Okay. For the most part. Good. Okay, great. Did I get anything wrong?
No.
Okay, good. Thanks so much for coming on and talking to everybody here. And I'm super interested in this DC only energy storage system. And you seem to be the expert on this.
Well, I'll explain a little bit like this. We have a DC ESS, which means that we've gone through certification for our battery storage system, our SimpliPHI 6.6 battery system, wherein it is certified as a standalone battery under UL 9540. And that means that all of the safety considerations, everything to protect that battery is integrated within the battery, and therefore it is not reliant on other pieces of equipment to provide safety as UL 9540 had previously been developed.
That's super cool. So like everybody else up until now has pretty much been having their battery listed with the inverter, sometimes in the same box, sometimes it's different, sometimes they're different companies. So I imagine when you do that, it gets really expensive because you have to go through the test with every inverter.
It does. It's really expensive. All of these certifications are very expensive for battery manufacturers. But part of that is the safety of the batteries as they go into this industry, as they go into people's homes, is paramount. And it should be paramount to every battery manufacturer that exists today. So these certifications are pretty intense. The testing is intense, everything from UL 9540A, where we go through a forced thermal runaway event and collect data and understanding of how the batteries behave. And that then influences your UL 9540 and how batteries are installed, how close they can be together, how they're put into a system, a room, whatever it might be. So yes, they're expensive, but I think they're very necessary to provide the level of assurance and safety to homeowners, businesses, and first responders.
Cool. And so there's UL 9540, which is the listing for energy storage systems, which is required. And then there's UL 9540A, which is called large scale fire testing, which is kind of a weird name for something that doesn't have to be big. It could be like the smallest energy storage system. So it's not really large scale. And I was wondering, do you think I have like this gas fireplace that I don't use much? Can I turn that into like a UL 9540A testing facility?
I'm not sure.
Do you guys want to like work with me on that? Just send me one of your batteries and I'm going to test it.
Well, it's a really interesting process. So all of our batteries have gone through UL 9540A fire safety testing. And we use different cell form factors, cylindrical, prismatic, pouch. And in that testing, what's required is that we modify the battery, we wrap the cells in heater wraps, and we put a ton of thermocouples all throughout the cell pack to measure temperature and different values as it's going through testing. So under 9540A, you superheat that cell, and it's surrounded by other cells that are being monitored. And you have to get that cell to go into thermal runaway. And in addition, you have to show propagation. Otherwise, you don't have a successful test. And so in normal operation, these batteries will most likely never get to these temperatures, but it's important to understand what happens when they do. So we superheat the cell. In our PHI and amplify batteries, we were only able to achieve propagation to a neighboring 2 cells. And we have hundreds of cells in these batteries. So they self-extinguish, but in that process, gas is released. And so we measure the gas concentrate and we determine if there's flammability or lack of flammability, how much gas concentration is actually released, especially if it's in an enclosure. So every battery goes through a cell level test, where they just do it at the cell and superheat it and watch what happens. And then you do it in a pack level. So that's the assembled battery. And then you go to unit level, which is multiple batteries in a system together. And all of that helps to inform the spatial requirements and installation under UL 9540. There is no currently unicorn battery that passes at the cell level. There's very few batteries that pass at the battery level. And then most battery systems get to unit level testing because we want to ensure that the batteries can be installed closer together, less than 3 feet apart.
And so these little, what do you call them, heater wraps?
Yeah.
And then you wrap them around the cells. And you said you're using all different kinds of cells, cylindrical, prismatic, and pouch?
Cylindrical is our primary cell form factor. Yeah.
So that's like a flashlight battery. And so you're just taking these individual cylindrical looking batteries. Oh, you got one right there. And so you're just taking these batteries, like same ones I have in my car, and you're wrapping them in these little miniature electric blankets, sort of like resistance heaters.
Exactly. Yeah.
And you can get them hot enough. And when you're doing that too, are the batteries, are they operating? Are they being charged or discharged?
The batteries do need to be at a state of charge, and they're not operating during the test.
Yep. And so then you get a battery cell cooking, and then you'll see if it gets its neighbor caught on fire or how many neighbors and all that kind of stuff.
Yeah, and they measure like the off-gassing, explosion risk, whether or not there's flaming outside the enclosure of the battery. And in the cases of our batteries, we have not had those types of effects. So it's really held within the cell and a neighboring cell that's touching it, which we have to do. Otherwise, we don't have a successful test if we don't have propagation. But after that, the battery stops. And so we've historically shared our test reports that show this spike when the battery off gases, or the valve here opens in the top and the gas comes out, and then a sharp decline in temperature as that propagation stops.
And I think I remember hearing sometime from somebody or at some seminar or podcast or something like that, where it was somebody from SimpliPHI, and they were saying they were having trouble getting the temperatures high enough to even catch them on fire because you're using lithium iron phosphate batteries.
Correct. That is a true statement. We built the batteries and the test equipment, everything that was needed. It took us a few tries.
Do you think your batteries are safer than homemade scooter batteries in New York City?
Yeah, and I think that these certifications have something to do with it. It would be an extreme black eye for a reputable manufacturer in this industry to manufacture batteries that have that kind of effect. And so that's why these certifications are important. It's important for people to understand what those certifications mean. Everyone from fire departments to homeowners, installers, These are important, and it's drastically different than DIY batteries from scooter batteries that don't have an ability to limit the charge. I mean, a lot of what we're seeing are batteries that have been overcharged. They're just left plugged in, and they don't have the safety mechanisms that are inherent to what we build as a battery storage product. And that's again coming back to the DC ESS. For us, we really wanted to go through certify the battery under 9540 as a standalone DC ESS system that can be paired with any UL 1741 listed inverter. And that was the intent, to decouple the inverter and battery if we could, because there was a lot of all-in-one where the inverter and battery are part of a single enclosure. And that didn't meet what a large percentage of the market makes, which is standalone batteries.
Yeah, and you know what's kind of different about this battery too is most any other energy storage system is coming through electronics before it comes out of the energy storage system. So it's coming out of an inverter that's going DC to AC or some sort of DC to DC converter. And I believe with your battery, I was just kind of looking at the data about it, is that you just have pretty much, I think it's 51.2 volts, right?
Mm-hmm.
And so you take 51.2 and you divide it by the nominal voltage of an LFP, that's lithium iron phosphate battery, and that's 16 cells in series.
Mm-hmm.
And then I took that 51.2 volts and I divided that into, it's 6.6 kilowatts. So I said 6,600 watts divided by 51.2, and I get 129 amp hours.
Mm-hmm.
And so that's kind of cool. That's the first energy storage system that I could tell you how many amp hours are in it.
Yeah, per battery. Now, if you were going to stack three of them together, you get three times, that amount of capacity. Mm-hmm.
It's just like old time lead acid battery calculations.
Yes.
And so like I do a lot of training and stuff like that. And it seems like for the most part, when you're teaching people about amp hours, it doesn't really apply to anything now. And everybody wants you to know about it and stuff, the amp hours. But now it is somewhat relevant with your batteries. And so I'm imagining too, like these batteries or energy storage systems, you don't put them in series, right?
Correct. They're always wired in parallel. And they're at voltage. So we've got a 48 volt nominal battery. And so it pairs really well with 48 volt inverters that are on the market.
Great. And do you have a list of inverters that it works with, or it just works with any inverter that?
In closed loop communication, we have a number of different inverter companies that we do work with. The battery is relatively new. So we came out with this battery, roughly started shipping around May. And for us, we want to make sure, even though we have the standalone DC ESS, we always do compatibility testing because we have closed loop communication. Sol-Ark has been one of those brands that we've had a long relationship with. And so the batteries pair really well with Sol-Ark. But there are a number of other inverter companies that will be coming out on our list in the coming months. And so I don't necessarily want to let the cat out of the bag, but we're in the process of qualifying about 19 different inverter companies.
Nice. And then if you're not working with those inverter companies or just like at some other inverter company, it'll still work, I guess,
Yeah.
and still be legal and listed and all that. Yeah.
Yeah. And so in open loop, the batteries will function like any other 48 volt lithium battery. It just requires some more programming on the inverter side. But there is nothing stopping someone from using this battery with any lithium supporting 48 volt inverter that's on the market. In addition, we do have our Energy Track app. So people who may not have closed loop communication with an inverter, they can still go online, go on their phone and see how that battery is performing. So our app will show you individual battery state of charge, its charging, discharging, and historical information. We wanted to, no matter what application, whether it was closed or open loop, to give someone a true indication of what the SOC is of those batteries.
SOC State of Charge. Woo!
Yes.
And so I noticed too that a lot of people in the industry call it a 48 volt lithium iron phosphate battery. However, I think It's a little bit different if you want to be technical on it, but that's just what everybody calls it. And so I think that comes from like everybody was doing lead acid batteries and they're calling them 2-volt nominal cells. And you put 6 in series and you have a 12-volt battery, just like what's in your car. And people were going, well, I could get pretty close to that if I take 3.2 times 4, and that gives me 12.8 volts. And it kind of works. You can almost just swap them out, but you might overcharge it a little bit, but it's not enough to be dangerous probably, because lithium iron phosphate batteries can be a little bit overcharged, more so than the types of batteries that have cobalt in them, types of lithium ion batteries. It's 51.2 volts nominal or 48 volts nominal?
51.2. 51.2 nominal. 48 volts is actually when the batteries are almost depleted.
Yep.
Yeah, so it's kind of an interesting, we actually charge batteries to about 56 volts or a little higher. And that would be like full data charge. And then 48 volt is very often 0.
Yep. Yeah. So just like with any battery, and I always like using like the car battery analogy because everybody's familiar with that. They call it 12 volts, but it can go down to like 11.4, but it's not healthy for the battery, and that's completely dead. And then when it's just sitting there charged, right now, your car battery, if you drive one of those old-fashioned internal combustion engine four-wheel devices, then you're at 12.6. It's sitting there. And then when you're charging it, it might be something like 14.4. That's when you're driving around playing the stereo. So it's always a range and things like that. And there's like nominal voltage. And so it's just sort of like the convention of the industry to call the battery 48 volts. And then I'm trying to have a purpose in life. And so I have to like try to correct people when they say things like solar panel instead of solar module.
Yeah.
Or,
It's so funny because I have, from working in lead acid for so long, it took me the longest time to start talking kilowatt hours. I was very much stuck in amp hours. That was how we sized batteries and sized battery banks. And so the same thing holds true for solar modules. I've always called them solar modules, and I'm now having to revert to panels.
Yeah. Yeah, it's just what people say. I catch myself saying the wrong thing every day, all the time. Yep. I might say solar panel, or the one that I hate it when every once in a while, once a month, I'll say like kilowatts when I mean kilowatt hours or something like that. And that's the one I would correct people on the most. Speaking of that, like I'm sure that your battery, the one that we're talking about, the 6.6 kilowatt hour battery, what do you say that the maximum output of that is?
It depends on the number of batteries in a stack. So if you have a single battery, it is 6.6 kilowatts.
So 6.6 kilowatts or kilowatt hours?
Both.
It's both. That's interesting. So that's like a 1-for-1. Makes it easy.
Yeah, with a single battery in the system, it's 6.6. But as we add more batteries to the stack, because the internal resistance between the batteries changes because of the way you configure them. What's really interesting, the 6.6, a single battery, when you have one battery in a system, it's also 6.6 kilowatts. So it's 1C.
Maybe we should explain what a C rate is too for people. So a C rate is the discharge rate of a battery. Since you can discharge the full battery in an hour, then that's a 1C C rate. So the way that I look at it is it's how many times you can discharge a battery in an hour. And a lot of times it's less than 1C because it might be like 0.5C. And so then if it was 10 kilowatts, then it would be 20 kilowatt hours. And then it would take 2 hours to discharge it. And so that would be 0.5C, or 1 divided by 2 would be like the inverse of 2. That's another way of looking at it. And some people too with lead acid batteries, I remember they get kind of mixed up because then they have like amp hour rate, and they go like, this is the amp hours if you take 20 hours to discharge it or something. And that's a completely different thing.
Exactly. Yeah. And so what we look at for our discharge rate, it changes. So as we increase the amount of batteries per stack, so we can do 20 kilowatt hours per stack. But the internal resistance between the batteries in that stack changes slightly. So when you have 3 batteries in a system, the discharge rate is 0.7C. So not quite as fast. You can't discharge the battery quite as fast,
Oh, because maybe they would heat each other up.
Yeah,
All
they do
right.
that, and you want to maintain the life of the battery. And
Mm-hmm.
so by limiting that discharge rate, you also extend its life. So with a three battery system, you're looking at 14 kilowatts,
Mm-hmm. Okay.
0.7 C. So that's power energy.
That's plenty. When you have three of them, you still have more.
Yes.
So you're taking three of these, and that's getting up to be just under 20 kilowatt hours. And
Yeah,
is that on purpose, I guess?
it is.
There's a 20 kilowatt hour number that's in all these different codes.
Yeah, it is on purpose. So when we were looking at building a stackable battery and something that had more capacity, we wanted to get as close to 20 kilowatt hours as possible. So each battery is 6.65 kilowatt hours. So if you take another decimal point there. So with that, we get to 19.9.
Oh, convenient.
Yes.
So, one thing that I think of right off the bat with that is the International Fire Code. And
Yes.
so, if you were not putting this on a residential building, I actually have it right here. It says 1207.1.3 scope in the International Fire Code. And it says ESS having capacities exceeding values shown in 1207.1.3 shall comply with this section. So that pretty much means you shall comply with the International Fire Code if you are over 20 kilowatt hours. So you don't have to deal with the International Fire Code. So you could go put a whole bunch of these ESSs on a commercial building.
Yeah, you can.
Mm,
I mean, there's other fire protection that's required, and we
mm,
do have a limitation on how big the system can get. So 120 kilowatt hours is the total amount of stacks that we can put together with this battery, which meets some small commercial as well as almost every residential application I can think of. There's some that are big.
I would think that you could probably have like a commercial building according to this and not have to use the IFC, the International Fire Code, if you had a whole bunch of sub 20 kilowatt hour energy storage systems, no matter if you had 100 of them.
Yeah.
Yeah.
And I think as we look at residential, it matters there too.
Yeah,
So
yeah, I know that 20 number pops up over there. So let me just kind of read that because a lot of people are interested in residential. And so that is in the 2024 IRC, that's International Residential Code. It says R330.5 energy ratings. Individual ESS units shall have a maximum rating of 20 kilowatt hours. The aggregate rating of the ESS shall not exceed, and then it has 40 kilowatt hours within utility closets, basements, and storage or utility spaces. And then all the other places can have 80 kilowatt hours. And just notice that 40 and 80 are multiples of 20. And then it says 80 kilowatt hours would be in attached or detached garages, accessory structures, exterior walls, outdoors, or on the ground.
yep. And
Hmm.
this is also, those values are replicated in the National Fire Code. So NFPA 855, Chapter 15,
Mm-hmm.
directly addresses ESS installation and its spacing. So that 20 kilowatt hours is that benchmark for the 3 feet of spacing between units, unless you have approved spacing lesser than that. Many jurisdictions currently are adopting NFPA 855 and they're requiring that 3 feet of spacing no matter what. That is the guidepost. That's what they're looking at, as opposed to looking at UL 9540 or UL 9540A. And part of what the industry is doing is trying to collaborate and work very closely with fire departments so that we can provide a test standard under UL 9540B that does have that feedback. We want to make sure that as we develop these codes, we develop these standards and tests, that we're taking all the stakeholders' viewpoints into account. And we're really wanting to educate on the safety of battery storage, to educate those that have to deal with it in a home, from first responders and such, what they're walking into. I don't know, I can't stress enough how important it is for battery manufacturers to understand these standards, codes, and tests. and to do everything they can to adhere to them, but also to educate those that are coming in contact with our products and understand these tests. They are important.
Great, great. Yeah, and just also for people to know out there is the UL 9540A, that's called large scale fire testing, and it's not a pass fail test. And if the UL 9540A determines that you can go closer than 3 feet between units, then you can. And most energy storage systems can go closer than 3 feet from each other. And you just have to install them according to instructions. And they have to have those UL 9540 and UL 9540A.
Correct.
Great. So how many of these things should I get?
I don't know. 120 kilowatt hours?
Oh,
You
at
got
least.
half?
I know. I do. I need it. I've got some plans and I need a lot of these. You know what I was thinking about is maybe I could take them and put them on some kind of rotisserie and spin them really fast. And then I would get flywheel energy storage. And then as I'm spinning them, I could lift them up really high. And then I can have gravity energy storage at the same time because batteries are kind of heavy too.
They are.
And so I will have the ultimate energy storage system, and then I'd have like the backup power too. And if the batteries are dead, maybe they're still spinning, or maybe they're up really high, all kinds of stuff. Can I work with your R&D department on that?
Sure, that would be something to see.
Good, good. That's a deal. All right. We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. And so another thing I wanted to read too is that the NEC needs to get it together, because if you look at the definitions of energy storage systems, it says one or more devices installed as a system capable of storing energy and providing electrical energy to the premises wiring system or an electric power production and distribution network. So now that there's a DC energy storage system, they need to change that. Unless, do you have a DC house? I think you should, because alternating current causes chakra imbalance. Did you know that?
I did not know that, but I know that
like 5G. Yeah.
Yeah, issues. Well, I watch a lot of ghost shows. So I know that electromagnetic pulse and things like that can cause strange feelings. So I'm assuming that's sort of related. Yeah.
Yeah, I think that like chakra imbalance can be caused by ghosts, like bad ghosts, but good ghosts can make your chakras better.
But what about EMP? So if is it all because you hear things, you get headaches?
Yeah, and I think so too. Like there could be a good thing and a bad thing, because you know that Star Trek is true and it's from the future, and they just came from the future and showed us what it looked like. And they have these things called tricorders. And what they're using is light. It's essentially light, electromagnetic radiation. And so there's so many different wavelengths, and they're all confused. And there's like a millions of different things going through my body right now, from satellites, from stars, from supernovas, from different cellular networks, and of course, just visible light and things like that. And so my stepfather, he's a medical doctor, and he has this device called a photon stimulator. And he looks at people with an infrared camera, and then he sends infrared light back into people's bodies under a special wavelength. So I just tell him that he has a tricorder, but it could be good or it could be bad. It just depends on the wavelength.
I have not heard of that, but then again, I didn't watch a lot of Star Trek.
Oh, you must be into Star Wars.
No.
Oh, okay. Okay. Well, you've got some homework.
Apparently just ghosts.
And we know they're real.
Yeah.
Well, cool. It's been really good talking to you. One more thing I wanted to talk to you about too, is when people are talking about this energy storage system, they talk about edition 3. What are they talking about?
Mhm. So edition 3 is the latest of UL 9540. It's the latest edition of 9540, which allows for the DC ESS. And so that edition 3 is the separating or decoupling of an inverter and a battery under the UL listing.
Okay, so on edition 2, could you have not had a DC only ESS?
No, under edition 2, you had to name the inverters. And so that did create a lot of challenge because you were, as inverter models change, as inverter companies continue to expand their line, you have to recertify every time. You have to go back and have them look at that inverter and sometimes do the testing if there's significant changes in that system to have the additional inverter listed on the certification for 9540. So as you can imagine, companies that are agnostic in their approach to the inverters they're working with, you are having to go through all of the different inverter models that are out there and making sure that they're part of your list. And so you end up getting selective and you end up ultimately limiting the installability of different inverter products.
Dang. So just maybe on like an order of magnitude, how much would you say that the listing test costs for UL 9540 and UL 9540A? Like 1,000, 10,000, 100,000, a million?
It's six figures.
Six figures. So like in the 100,000 range. Okay. And so that's like every time they change something with the inverter or you change something to make your battery better, something like that.
Yeah, I mean, there's different levels. So as you go through testing and certification, depending on the change, if you are modifying an existing listing and it doesn't require a lot of full-scale testing, very often you can go through qualification and providing data and analysis, and you can do an update or a revision to your current listing. It really just comes down to what those changes are. If you're making significant changes to the manufacturing or what we call a named component within your listing, that requires additional testing. And you need to make sure always that you're ensuring the safety of your product. And so that's why that testing is important.
Okay. And so also too, when I said six figures, 100,000, it could be like $999,000. No, something like that.
It could.
Yeah.
That's on the
And
high end
with
for
a
sure.
99 cents in there somewhere. And so we really should do that thing with my fireplace. Think, do just we get time to open up one of these labs.
Yeah, there are more labs that are opening up, but we always want to make sure that it is a nationally recognized test lab for that test. These are important tests and they need to be consistent and they need to be consistently done across labs. And it doesn't serve us well if one doesn't do the testing quite as well as the other one.
One time I found an energy storage system that was being sold for $9,540. Would that qualify for 9540?
No,
Oh, dang it. But maybe the inspector would know the difference.
I would hope we do.
Okay. Maybe it's too expensive.
No, not too expensive.
Uh-huh. Okay. So where can people figure out where to buy your batteries?
Yeah, so we work with a number of well-known distributors across the country. You can always visit energy.briggsandstratton.com, and we have a where to buy page. If you're a homeowner that's looking for a 6.6, we have a number of installers across the country that are familiar with our product. They've gone through our training programs and really understand our storage products. And you can find them all on a map. So we have them all listed on a map where you can buy our products. And then you can also just give us a call or shoot us an email. So ESSsales@briggsandstratton.com. Our team is always willing to help answer questions and to point you in the direction of someone who can get you the product.
Cool. Very cool. And just before we go, I also wanted to ask you about CALSA. So you're on the CALSA board, the California Solar and Storage Association board, and CALSA is super awesome, and they have like a really fun party that I saw you at. And you know what's cool about that party too is at the Berkeley City Club. That's where I learned how to swim. I learned how to swim there. It's this like old building designed by Julia Morgan, and it used to be called the Berkeley Women's City Club until they had to get all politically correct and invite men to it. And then my grandpa, he was in the Berkeley Breakfast Club. And so in the 90s, I was going there with my grandfather. I was the youngest member of the Berkeley Breakfast Club for a while, which was...
That's awesome. It is a beautiful building. I look forward to the event every year just so that I can kind of explore this castle-like building in the middle of Berkeley.
Yeah, Berkeley's cool. I was just down there eating dinner there last night, right around the corner.
If you are in this industry, especially if you're an installer or someone that's doing business in California, you should be a member of CALSA. But even if you're not living in California, we have member companies that are from all over the country that have a vested interest in what happens in California and in the state. CALSA is the chapter organization for SEIA based in California. And what we do is we fight for our solar industry and distributed energy storage and solar. So CALSA is responsible for a lot of the lobbying efforts and fighting for these standards, policies, et cetera, that really help support the growth of distributed solar and storage in California. So really advise everyone to be a member. This is the team that's fighting for you.
Yeah, and it seems like you have SEIA working on the national level and CALSA, and it's like between CALSA and SEIA, that's like about like 90% of lobbying, right? And it's almost like CALSA is very, like, I want to say bigger than SEIA or anything like that, but they've been around for a long time. You know, I'm not sure if CALSA or SEIA has been around longer, but I know NorCal Solar's been around for 50 years. We just had our 50th anniversary party. And back then, it was like people didn't even know what solar was, you know?
I know, that's a long time. This industry has been around longer than most people realize. And to be one of the oldest startups ever. So, but I think we're maturing, and, you know, California has been traditionally almost 50% of the total market in the US. And so that's why there's so much that happens in California that filters out through the rest of the country, and why they've been leaders in solar and storage. But there are other chapters, state-based chapters throughout the country. New York has a huge chapter, as does Colorado, Oregon, Washington. But if you're interested in a chapter that's maybe closer to your area, you can always visit SEIA.org, and they do have a chapter list. And many of these chapters have local networking events. So CALSA, we have events all over the state where installers and people can come together and network and learn and fight for things that are maybe more regional or local to the challenges that they're facing in the state.
Great, great. And by the time this is released, I will have already done my NEC presentations at MoSEIA, that's Missouri SEIA. I'm heading there soon, but it'll be over by the time this is released. And Tennessee. And you know what that stands for, Tennessee. It just sounds really cool. You know,
it sure does. Crazy. Tennessee, I just was reading a survey from Energy Sage, and Tennessee is actually ranked #1 for their interest in battery storage.
Wow, that's pretty cool.
So more people are asking about battery storage in that state than anywhere else in the country.
Well, I better tune up my presentation for that, to keep that in mind. And I did put your 6.6 kilowatt hour, 6.6 kilowatt, I could also say, and not be wrong. That's a good reason why to have them the same. So if you say it wrong, you got it right. And I did put it already in my presentations. So pretty cool to see that DC only ESS energy storage system that's direct current. Very cool. Yeah, and I do see too with CALSA, like if something good or bad happens to California in the solar industry, other states copy it, you know. So we want to make sure that good things happen. So everybody send all your money to CALSA right now. All right. Well, thanks so much, Sequoia. Is there anything else that we should cover?
I have one question for you.
Hmm.
So we didn't really close off the DC, having your home powered off of DC.
Oh, okay.
Yeah, so you said you were interested in that.
Yeah, is it like, I mean, you hear people talking about it and it sounds kind of cool. And I know like back in the 90s, we had this place that was running off of solar and had some DC loads and stuff like that. But, you know, it just seems like nobody's doing it. Or sometimes you see people that don't understand the technological part of it. And they think that you're going to have USB cables in every room powering your house. I'm not sure. I mean, USB-C is kind of getting better and they could put more power out of it and stuff like that. But I mean, it would be cool. And I just don't know, is it going to happen?
When I was at Backwoods, we would have a lot of off-grid customers that had everything DC. We had DC LED lights they could use, DC wiring in the house, DC refrigerators, and their whole home was powered off their battery DC. It's interesting. I just had a conversation with someone who is building modular homes that are all DC. So,
wow, cool.
He's pretty sold on the technology and thinks that it's something of the future.
Is it something that we can talk about, like the name of the company that's doing it? Come on, tell us.
I shook my head no. But I think it's interesting. I think there's always enthusiasts for DC only systems. And I think that there's definitely an application. We see it in remote applications quite a bit, where we have DC repeaters or things that are in the middle of nowhere. But it isn't as prevalent because our grid has been built on AC power.
Yeah. And they just mass produce AC stuff. And
yeah. I mean, there's benefits to carrying that higher voltage. You get smaller wires and things like that.
Yeah. I'll be waiting for this, or maybe I'll just kind of rig it up and I'll get one of your ESSs and then just try to figure out how to make it power my house with DC. I'm going to get a bunch of 51.2 volt appliances.
Nah. But most people are going to use an inverter. And I think inverter technologies have come a long way as well, much more efficient. And
yeah.
everything we own is really AC.
Yeah, I remember like our 90s system, I would be in the house doing stuff, playing the radio in the middle of the day. And then all of a sudden the song would get quiet and the radio would turn off. And then I would have to turn on a light bulb to keep it going. And I guess the cool thing about that is in the middle of the night, when there's no loads, you would be like totally at peace, like camping, you know? So without all of that alternating current going through your walls. But nowadays people have these little loads called phones and they need to charge them with like, you know, very low power and they're not going to turn on the light bulb. So they would just set the inverter so it would just stay on. But okay, we got to work on the DC only house. And I'm actually even thinking about a DC microgrid for my own purposes, but I got to work on it a little bit more. Then I'm going to ask you some questions.
Well, yeah. And one of the things, like one of my segues in my career, I worked with a social benefits company called D-Grid. And what I was responsible for was designing the solar system with batteries. And we provided DC fridges, large scale DC fridges throughout the world. And so those were entire systems with solar batteries powering 20 meter cubed, 40 meter cubed refrigeration units that were being used in Africa and remote parts of the world. And it was completely off grid, completely DC. And then we would sometimes have LED lights on the outside for a community, again, DC. Those were standalone DC systems as well.
Wow, that's pretty cool. And they had batteries or they weren't direct?
No, they had batteries. Yeah.
Yep. Well, that's super awesome. So when I figure out my microgrid thing, I'm going to call you up. Maybe we could do this again sometime.
Okay. I'll come out and help you.
Okay. Sounds good. Cool. All right. Well, thanks so much, Sequoia.
All right. Thank you, Sean.
All right. Have a great day.
You too. Bye.